Hey guys, today we're going to be covering the topic time value of money. This topic is pretty basic, but it's important because we're going to be covering advanced level concepts of corporate finance. We're going to be speaking of NPV, IRR, payback, and discounted payback. So it's kind of important that you learn the basics over here. Alright, let's get on with it. Money has time value? What's that? Isn't it enough that money has face value or monetary value? Why does it need time value? The concept here that I'm trying to teach you is pretty simple. 100 rupees today is not the same as 100 rupees tomorrow, is not the same as 100 rupees after 1 year. Let's take a really simple example to understand how this is done. You have two gentlemen over here. Each one of them is going to make you a small offer. You have to pick one. Let's see how we're going to go down with this. Trump says he's going to give you 100 American dollars. Cut the deal with him. Kim says he's going to give you 200 American dollars, but after a year. Pick him. How do you decide which is the better offer? You could just be like this guy, take the money and forget about it, or we can logically work our way around. How do you do this? Simple, you time travel. I'm not joking, but mathematically, we can time travel. Let's see how we do this. We need to remember that money can only be compared in the same instant of time, in the same moment of time. 1 rupee today cannot be compared to 1 rupee after 1 year. It has to be both either after a year or both today. Let's take the first approach. Let's travel to the future. This approach is called compounding. Let's say I take Donald Trump's offer of 100 American dollars. I invest it at 200%. Well, I have Jewish friends, so they make good money. I put my money with them. They give me 200% returns. If I put $100 today in that opportunity at 200%, after 1 year, I yield 300 American dollars. Don't worry about the calculation. We'll get into that later. Right now, I just need you to understand the concept. $300 after 1 year can be compared to Kim's offer of $200 after 1 year. Of course, it's a way better offer. Let's stick with Donald Trump. Let's try the second approach. Here, we're going to go into the future, take Kim's money from him, and boil it down back to the present. This approach is called discounting. It's called finding the present value. Present value is nothing but you can travel to any point in cosmic time, take an amount over there, and find its value today. Let's take the same discounting rate of 200%, which is also the opportunity cost of my money. $200 1 year hence, discounted at 200%, yields for 1 year yields about $66.667 today. Again, do not pay attention to the formula, we'll get to that later. Right now, only understand the concept. In the first approach, what I've done is I have invested Trump's money today for 1 year and gone to the future to see what its yield and then compare it with Kim's money. In the second approach, I just went directly to the future, took Kim's money, and discounted it back to the present to compare it with Trump's offer. In either case, Trump wins. An important assumption that we made over here is that we can invest our money at 200%. My friends are Jews, yours may be good Jews. They may probably be able to grow your money at a far lesser return. For example, if you have an opportunity to grow your money only at 100%, $100 invested today at 100% after 1 year yields 200, which is the same as Kim's offer. Going to the future, taking $200 from Kim and discounting it at 100% yields $100 today, which is the same as Donald's offer. Assuming both of them keep their word, that there is no risk of default, and if I can only grow my money at 100%, then we can say that Trump and Kim have the same thing to offer, in more ways than one. Let's understand the first approach. How did I go to the future? How did I calculate this? How did I make the comparison? Pretty simple. Suppose I have 100 rupees today. I put it in the bank for a compound interest of 7% per annum for 3 years. After 1 year, the interest would yield 7% on 100. Yes, you're not a genius if you've answered 107. Everybody knows this. But we are going to derive the method of compounding. The way it's done is 100 yields 7% on 100. This can be written like this. Please do not make me go back to arithmetics. I'm not here to teach you math. Let's call this as A. Now A is what I have at the end of year 1. Now the way compounding works is at the end of year 2, I receive 7% on A, not on the original 100, but on what I've already made on the original 100, which is A. Basically, at the end of year 2, I have A plus 7% of A. Another way of writing this is something like this. Resubstituting the value of A, this is what I get. Taking 100 common, this is what I get. I know it looks a little off. Let me give you a better view of things. This is where you and I are, time 0, where we only have 100 rupees. At the end of year 1, this is what we make, which is the same as this. This is A. At the end of year 2, A becomes something more, which is again getting 7% interest. At the end of year 3, this is what we get. Did you see that yet? Let me refine it a little more for you. Let me put it in a table. At period 0, I had 100, which is the same as 100 plus 1 plus 7 by 100 raised to 0. Do you see? The number 0 and the power 0 are the same. At the end of year 1, where 1 year has lapsed, on the timeline, the number 1 signifies the end of the first period. It means that the first period has lapsed. It's not the beginning, but it's the end. At the end of year 2, this is what I get. At the end of year 3, it doesn't take a genius to answer that the number just changes to 3. That's how we discuss the formula. P is the principal that you originally invested, which was 100. R is the rate of interest per period. It's very important that you notice the period in the rate of interest. I'm really sorry if this sounds wrong, but it's just the way it is in the world of finance. N is the number of periods for which the interest is compounded. The unit of the rate per period and the period must match. Don't worry about the statement. We'll figure it out in the next slide. But right now, all I want you to understand is this table. There. I think you know how to compound. You're pretty sorted, but wait. Everyone is not going to be talking as simple. There's going to be some people who are going to be telling you that they have 100 rupees. They wish to put it in the bank for 18 months and the money is compounded semi-annually for 14%. How much would I make? Well, believe it or not, the calculation is actually the same. The principal is the 100, which is the same as the previous one. Now the rate of the interest. Here's where the catch is. 14% compounded semi-annually. It just means that I get 7% every 6 months. If I get 14% for every 12 months, but it's compounded semi-annually, then every 6 months I get 7%. Now the unit of my period has become 6 months and not 1 year. Since the money is invested for 18 months, my period is 3. For 18 months is just 3 periods of 6 months each. So again, R is rate per period. N is the number of periods. The unit must match. The timeline again is exactly the same. The only thing that you need to understand here is that 7% per 6 months is the same thing as saying 14% per annum compounded semi-annually. If somebody tells you that they are making about 10% semi-annually, it means they're making 5% every 6 months. If someone's telling you they make 12% compounded quarterly, it just means they're making 3% every 3 months. Tomato, tomato. There, you're done. I think we can move on to the second approach. This is discounting. All you need to remember from before is you need to match the unit of the rate of return with the number of periods. The rate at which we discount the money, we first go to the future, take the money, and then discount it back to the present. In this approach, we are only and only concerned with the present. What is there in the here and now? Nothing besides the here and now. So the rate at which we discount it is called the discounting rate or the WACC. WACC means the weighted average cost of capital. Let's say you wanted to start a business. The different ways you can raise money is maybe approach a bank, promise a collateral, they give you the money. The interest that the bank charges you becomes your cost of capital. Another way of raising money is you approach the public, you make a promise. You give me some money, I'm going to be paying you interest on that, and I swear I'll return your principal. The interest is over here is called the coupon, and the money and the legal agreement that you take is called a bond. Another way of raising money is using equity. You can just ask the people you know, you trust, you love, or the general public by getting listed on the stock market to invest in your company. You need not pay them an interest, but they will enjoy your returns, your profits. In the real world, money is raised through all of these platforms simultaneously. Since the money is raised in different weights, we say it's a weighted average cost of capital. The required return, or inflation. Inflation is an interesting concept. What your grandfather could buy back in the day for 1 rupee, today you can't even buy that for 100 rupees. So probably if you had your fight with your grandfather as to he tells you why are you spending so much, he's not acting cheap, neither are you acting dumb. It's just that the both of you do not understand the concept of inflation. Remember, to find the present value, we go to any point in cosmic space-time, find an amount, and discount it back to the present. The formula for discounting it is pretty much the same as compounding it, except for the multiplication sign becomes a division sign. Here is the formula. We're going to take one interesting example to see and to understand how discounting works. Meet Bob. Bob and I went to university together. Bob was a geek, but Bob was smart. Bob had a really cool pickup line, and today I'm going to tell you about how he did it. He went to a bar once and he said, "Hey, I'm Bob Wadwa. In 5 years, I'm going to be worth $100 million. True story, marry me?" For all those of you who are wondering whether this pickup line worked, the answer is no. Why? You're going to find out. Let's analyze our bachelor's worth. I believe Bob. At the end of 5 years, Bob is going to have $100 million. Don't ask me how, I just believe him. But what does that actually mean? I told you we are only concerned with the present, in the here and now. I am not interested in what's happening 1 year from today. I want to know what's happening today and today itself. Let's find his worth. Inflation is another way of saying that money depreciates. The fall in the purchasing power of money is the depreciation of your currency, which is nothing but inflation, the reduction of value. Now let's solve this problem. I'm first going to find out what Bob is worth 2 years from today, considering the money depreciates at 5%. This 5% is just my discounting rate. Here's the timeline. This is where I am today. This is where Bob promises to have $100 million. Now, to find the first question, I want to know what he's going to be worth over here, 2 years from today. Alright? How am I going to do this? Do you remember the formula I showed you in the last slide? Don't worry, we're going to put in the values over here. Here's the formula. 100 million is being discounted at 5%. What's up with the 3? Well, even though I only want to know his value 2 years down, but I am discounting it by 1, 2, and 3 periods. Well, so that's why I have the number 3. If I calculate this, the answer is 86.38 million. Wow, not bad, Bob. You're doing pretty good, I must say. Alright, let's go to the second part of the question. What if my assumption of inflation is wrong? What if the inflation is actually 7%? Money depreciates way faster. Here I want to find the present value. So I again take the 100 million 5 years down, and I try to find out what does it mean to have the same amount of money today, factoring in inflation. The formula is the same. My principal is 100 million. My discounting rate is 7% over here. Why 5? Well, because I want to discount it back to 1, 2, 3, 4, and 5 periods. When I solve this, the answer that I get is 71.3 million. When Bob promises that 5 years down he's gonna have 100 million, it's the same as saying that today Bob has 71.3 million. I don't think that's really true, but wait. It's 71.3 million dongs. If I convert that into American dollars, it technically means that Bob has 100 million dongs after 5 years, being synonymous to having just 3,200 American dollars today. Wow, that's what the girl figured out at the bar. She looks smart to me. Well, Bob, I'm sorry. Better luck next time. Well, that's enough for today. I hope you get all the basics straight. We're going to take you through more advanced concepts, perhaps in our next videos. Stay tuned, write to us if you would like us to cover some topics that you did not understand or you'd like to understand. This is us signing out.